Congratulations on finishing the first two lessons. Now let's take a look at our final lesson on properties of things. Throughout the course, we've seen things that are wildly different. Now, if they are so different, why can we use the same kind of elements in OPM to model them? How do we distinguish them? Well, this is when the properties of things come in. Let's take a look at the first property, called the perseverance. Perseverance concerns whether the thing persists over time or is transient. If it persists over time, which means it's persistent, then it's an object. If it's transient, then it's a process. As we'll see throughout the course, persistence and transience is a recurring and a common theme in OPM where a lot of foundational theories are built upon. So perseverance here is simply a property that tells you whether a thing is an object or a process. Then for the second property, we have essence, which concerns whether the thing has a tangible form or not. So you may have guessed correctly throughout the lessons, when an object or a process has a shadow, it is a physical thing. So things like a book or the driving process, because they have tangible forms, they're called physical in OPM. On the other hand, for things like an idea or thinking, which don't really have a tangible form, we call them informatical, and we take away the shadows. And it's also quite an easy thing to remember because only physical things can cast shadows. Now, you may argue that the thinking process itself involves neurons firing signals within your brain, so can't this be physical? Well, this really depends on your modeling intent. In here, I'm trying to convey thinking as a general abstract concept, so that's why I have designated it as informatical. But if you are modeling thinking in a microscopic level and explaining how the neurons work together in order to construct a thought, then of course you can define it as a physical thing as well. And besides these two properties, we also have another property called affiliation, which concerns whether the thing is inside or outside of our system of interest. Now, system of interest is a very important concept in system modeling, because without a very well-defined system boundary, you won't be able to tell whether something is internal to your system or external. And in OPM, we call something within our system of interest systemic, and things that are outside of this system of interest environmental. Whether a thing is within your system of interest really depends on your perspective and your modeling intent. The same thing can be systemic in one model, but environmental in another. Let's take aircraft as an example. If you're modeling your flights as an airline company, then the aircraft you own and their flying processes will be systemic because you have control over them. However, the air traffic controller in this model will be environmental because they are not under the airline's control. On the other hand, if you're modeling this as the air traffic control, then those aircrafts and their flying processes will not be something that you can control, so they will be environmental, and only yourself, the air traffic controller, will be systemic. So whenever you struggled in determining whether a thing is systemic or environmental, just ask yourself if you have control over that thing. If you have, then it's systemic and it will be represented by a solid border. But if not, then it is environmental and it will be represented by a dashed border. So all of these properties in OPM are independent or orthogonal to each other as well. A thing can both be persistent and also physical and also systemic at the same time, just like the aircraft object when you're modeling it from the airline's point of view, or it could be transient and physical and environmental, like the flying process when you're modeling it as the air traffic controller as well. And this is why OPM can keep its ontology very concise and simple, because the different properties that we assign to a thing help us understand its nuances. So we don't need other special classes like external objects or internal objects, tangible processes or intangible processes. We use all of these properties as a mechanism in order to convey its nuance. So now let's take a look at how we can assign these properties in OpCloud. Okay, so let's take a look at our OpCloud model in here. Right now we have the aircraft object flying and also air traffic controller. Let's pretend that we're modeling this from an airline's perspective. The aircraft here is informatical right now, and we want to change it to a physical object. So to do that, just click onto the aircraft object and find this Change Essence button from the top menu bar. You can also see its depiction of a shadow and just click onto it. And you can see aircraft now has a shadow, meaning that it is a physical object. And for the air traffic controller, we say that it is outside of our system of interest. So we want to convert it to an environmental object. To do that, find the dashed border here, which has the name change affiliation. Click onto this button and you can see air traffic controller now has become an environmental object. Note that these two buttons are toggle buttons. So depending on your needs, you can change their affiliation and essence to the opposite value as many times as you like.